down to Florida, Port St. Lucie, to visit the TAMCO factory. They've got over 400,000 square feet under roof and produce a ton of product for City Electric Supply. I'm excited. This will be a first time. Check it out with me.
And then we have machines like this, what we consider soft tooling. So our hard tooling would be any of the universal bodies that you see down there, standard chopper, high bay, whatever it may be. That body is never really going to change in shape. It's always going to be a 2 foot by 4 foot body, or a 2 by 2, a 1 by 4. So what we do is we create a hard tool for those. Those go on our machines over here. Raw coil comes in, they go into the designated hard tool. They kind of give us the internal features to make the light fixtures and the necessary features that we required for LED boards, LED tubes, fluorescent tubes, and all that good stuff. So what this one here is, it's a soft tooling CNC turret punch. What we do is we take the universal body that comes off a hard tool, we go into software, we design out the shape of the body. You can also do, we're using probably 30% of its capabilities. It's just straight hole punching. It's really good at forming dimples, knockouts, lances, and all that good stuff. So a lot of HVAC guys will use a machine like this to do the outside of basically an air conditioning unit with all the louvers and stuff. That's where these machines come into play. I can also get cut off royals and disc where I can actually slice material and do stuff. So the gutters that you see above us, once we get into manufacturing those, you'll start having dimples and standoffs. They'll be on this machine here. So we're designing fixtures around the machine that we have, kind of put it more into play.
So if it's just mostly for order, I can do anywhere between 200 to 300 bodies a day. If it's just for stock, you know, depending on it, again, what the order is on there, roughly around 300 to 400 bodies. But that's strictly just staying on here all day, making sure that all that is taken care of.
All right, so this one here is usually step 2 or 3, depending on what it is. It's going to be an LED board application, and you get some hard tool, soft tooling on the turret, and then over here the panel bending. So this is Salvanini, it's an automatic panel bender. Basically going to take a flat shape, throw it into the program, and bend it up to its final form. The first thing you got to do is tell the machine what the body looks like and how big it is. So the machine knows the plate size. I then take my Z dimension here, my X dimension here on my last bends. I need to find a center point of that fixture, which is usually right here where this hole's at. I'll do a standoff to where I offset the hole. From there, the machine knows how big the body is and knows the center of the body based off of my bend program. I then throw in 2 reference points, which is usually the end corners on this side and that side. That corresponds to those blocks up front. So if you look inside the machine, the little blocks that pop up in the front are my reference points. The manipulator arm coming down is my center point. If I have more than 4 inches on the internal field of my fixture, I can use this machine. Anything smaller than 4 inches in here, I have to then go to a manual brake press. The difference between automated and manual, the operator over there has to memorize which way to load the body in there and it's out and rotate it. So I can definitely do this exact same body over there, but then the operator needs to put it in there, bend it, take it out, flip it, do all this crazy stuff and memorize that orientation to get that same body. If this machine was to catch on fire and break down, he's going to be doing it, right? But as far as speed, efficiency, and keeping our costs lower, this is where the machine comes into play. With any of our larger bodies, we call them a unibody. We like to put our end caps on the actual fixture. That way we don't have a separate die making the end cap. We don't have a separate operator screwing that end cap onto the fixture. You can see anything like the high bay, the IBLED, the TCs, the prompers, all that good stuff have the end cap on there. We design this little tab. That tab gets folded down into that slot. I have a little tool that will then take that tab and then fold it over, hem it down. From there, it gets staged on a pallet, directly ready for paint. And then we go to the next step. Everything is ran with an automated prop film, right? First thing we do is we design our tooling to run a job, and that's the only job it's ever going to run. So the tool is designed around the part. The part is then correlated to our steel. We buy our steel as far as thickness and in width of our scheduled part. From there, it goes onto a decoiler. The decoiler is basically going to take that steel coil, flip it up on its side, hold it so we can start unraveling it. It then goes through a straightening process to kind of flatten that metal out. From there, it goes to the feeder. The feeder is our programmable option to basically tell that material to be pushed in certain dimensions. Y'all know what that is, right? Take it, pass it around, put it in your pocket, take it home. I don't care. Souvenir. this thing comes in multiple different lengths. You have a 2 foot, 3 foot, 4 foot, 6 foot, 8 foot. So if I wanted to run an 8 foot component in one hit, I need a die that's about 10 foot long. And then I'll have a hard time running that same die for a 6 foot, 4 foot, 2 foot. So what we do is we design the die to have the features that are in this body. You see we have a bunch of different features. Each set of features is a different die shoe on that body. So this is the smallest machine when it comes to Mazak as far as the power side, 2.0. So they have a 4.0, 6.0, 8.0, 10.0, and probably about 15 different table sizes. So it's a 2,000 kilowatt with a 5 foot by 10 foot table. So we had this machine on the shop floor before we bought the turret machine. So I bought that machine knowing I had this material already on hand. So if this thing was to break down, I could take a good portion of these programs, throw them out there, and still produce a part. It's not going to be the exact same shape because this will do basically whatever shape you want. Out there is going to be squares, rectangles, and predetermined shapes, right? But it is a backup. So we invested that type of money in this machine to be in control of testing, prototyping, and the first lifespan of fixtures, right? So the iAbility 4 foot 4 light, that is currently on revision like number 13. So from 1 to 13, there's a bunch of tests that we do or changes that we do based off of our feedback that we make during the operation inside, as well as customer feedback from hanging standpoint or mounting or install standpoints, right? So with all those changes have to be done somewhere. If we create a hard tool from get-go and then have to change that thing 12 times, that's going to get very expensive. So a hard tool can range from $5,000 to $200,000 depending on the shape of the hard tool and the size of the hard tool. So if you have a $100,000 die and you're trying to do testing or prototyping, you're going to drag out a bunch of money and time because creating a hard tool, you have to cut your block, mill your block, wire EBM your block, heat treat it, put it in, and once you have a D2 tool steel that's heat treated, you're not going to start drilling holes in that thing. You'll be breaking all fits. And that's why we have this machine here. I can take any one of my programs that's in here if you want to make a change. So anytime that we do a new board or a new driver, and that driver is a ½ inch longer than our previous one, that is considered a revision. That hole change has moved a ½ inch. We have to then make that new hole, test it, make sure it matches our drivers and all that good stuff. So I can take a program from here, throw it back into my computer, within a minute, 2 minutes, I can have it back in there cutting. If I need to do that on a hard tool, you're probably taking a month to do so. So the way this one operates, on the backhand side, there's a fiber optic generator. The generator has 4 diode packs. Each diode pack has about 80 strands of fiber optic glass cable that measures about 8,000 in diameter. From there, it comes to the machine. It gets focused into this tip right here. This comes into the unit. All those glass fiber optic cables come to a focus point. That focus point then goes to a magnification process. Right below the orange ring, there's an optic box in there. It's about 4 by 4 by 8. It has 3 magnifying glasses in there. Each one of those glasses costs about 15,000 bucks. So you're taking a light, you're getting magnification through it, and it comes out strong enough to penetrate your steel. I was able to get through a ½ inch steel plate with this machine. I've gotten through 1/4 inch AR plate by just ramping up and maxing it out. So it's a smaller machine. If you start doing the 6,000, 8,000, 10,000, your material gets a lot thicker and your cut speed increases with the thicker steel. This one right here on the 24 gauge galvanized, I'm about 1,250 inches per minute. Once I get to a ½ inch steel plate, I'm about 12 inches a minute. So very, very slow when I get the thick material because I'm maxing everything out and I'm basically overriding all this little safety warnings just to be able to get through it. So we bought the machine knowing that we're only ever going to really cut 24 gauge, maybe some 13 gauge, nothing real thick. Our common material is 1/8 inch, 16 inch. I have no issues with that, about 500 to 600 inches per minute. It's about 8 years old and I've had maybe 2 months of downtime since I got it. That's install time. So when we first got it, there was a recall on some of the airlines. So the airlines started to break down and make their way into that optic window. So that thing is a sealed unit. So the airlines broke down, literally one speck of dust on that optic window will turn into a hot spot on the fiber optic cable. So on the tip of this cable, those spots are burnt into my cable. That's why I have a damaged cable. So an airline broke down, got 1 or 2 specks of dust on that lens, created a hot spot, burnt the hot spot into the cable, and now you're at a $60,000 repair bill. So when they come in to repair that, they basically bring in like a little vacuum chamber with mittens in there, and they basically rebuild it in a vacuum chamber so they don't have any dust particles on those lenses. Around CES, we started manufacturing strut in-house. This is the machine that we invested $1 million in to do so. So pallets of strut are over there. That's the stuff that we've already pre-made. Everything on this part of the building right here is all designated strut, and it's all communicating to each other. So every machine is ran off of sensors that it all talks to each other. So as we start it up, the very last process is the roll former. That is considered a pulling machine. That is going to pull steel out. The very last pit where the material is at a bow, there is laser sensors in each section of those pits. Once the roll former pulls the steel, that material rises, trips the laser beam. That laser beam then turns on the stamping machine and the feeder. That is going to start pushing material in and stamping the ovals out. Once it pulls the material in that little pit there up high enough, it's going to then trip another laser beam. That is going to then turn the straightener on, the accumulator on, and the roll former here. So everything talks to each other. So you can have 1 to 2 man operation here, basically running all these machines in line, and as it's running, the material is going to be fed through 100% of the time. So this one right here is what we added into the unit. This is called an accumulator, a loop, or a hopper. This machine basically allows us to run 100% of the time with never stopping. So the coil is roughly about 5,000 pounds. This machine, if I didn't have this, would eat that coil up in about 15 minutes. We would then burn it out. I would have to throw a new coil on, refeed it back through the system, run it out. 15 minutes later, I'm doing that process over and over and over. So this one right here is basically a hopper. We take 5,000 pounds of steel, load it into the hopper here. It basically holds it. This machine can then push material in and out at the same exact time. So as this coil runs out, we will stop it right here about the welder. This will get cut off, it will stop. The hopper is still pushing material out. We then throw the new coil on, weld it together, and then feed it back into the hopper. So as you can see, material comes into the bottom, it comes up, it spills up. Once it gets to the center here, it then flips over on itself, and then it starts feeding out the opposite direction. So I can in turn push material out at the exact same time I'm pushing material in. From there, if you want to walk on this side of it, it comes through a straightener. If you look at the material right here, it's got a lot of waves in it, right? So then it goes through the straightening process to kind of flatten it out. Once it comes out, it should be perfectly flat. And then it comes into the feeder. The feeder then goes to the stamping machine that is going to put our oval slots in it. So we started manufacturing strut about the beginning of July. We had some material issues that we were waiting on because it's a new material for us, so the mills were a little bit behind on it. So we fell behind schedule a little bit. We started ramping up our common sellers, our 12 and 14 gauge deep and shallow slotted. We got to a pretty good, decent point. We then brought the company who built the dies for us for this machine. They came in last week and we designated all of last week to testing and tuning our 12 gauge shallow and our stainless steel. We did not have any stainless steel strut on site before last week, so they know what they're doing a lot more so than we do when it comes to roll forming. We have a very small section of roll forming over there that we just throw parts in and spits it out. We know how it does it, but they understand the strut because they built it for us. So that is our stainless steel strut. Hopefully in the next month or two, we'll start having some of this stuff on the floor. We're reaching out to our mills to get some pricing on quotes, and we'll start bringing more steel in where we can start running this stuff out. So right now we have changed out the dies. We're fine tuning the angle so we can get it into our cutoff die properly without doing any kind of damage. So that's what we're working on now, is just doing the fine tuning on the angles. We know at some point we want to be able to offer any color available on the market at a fairly inexpensive rate. So we bought a machine that has that capability to do so. We don't push custom colors yet, but if you have custom colors that you are reaching out to or you want to do, send us an email. We'll get pricing and quotes on it, and we'll give you that information back. So depending on the color itself, there's a couple different ways I can buy it. If it's a common color that the manufacturer has readily available, it's on the shelf, I can buy 5 pounds, 10 pounds, 20 pounds, 1,000,000 pounds, whatever you want. If it's an oddball color that they don't typically sell on a day-to-day basis or have on the shelves, they're going to make it to my order, and they're probably going to have me buy 500 pounds of powder. So if you're only wanting 2 fixtures on a weird color that I have to buy 500 pounds of powder on, unfortunately you're going to pay for that powder, because I might never use it again. So depending on the color, send us a request, we'll reach out for pricing, we'll send that pricing back. If it makes sense for you, if it makes sense for me, we'll do it. So this one here, the way this one operates, you have a conveyor belt that runs the entire span of the unit, roughly about 110 feet or so inside. This line here is then mirrored on the outside. That's where the operators hang out most of the day, load and unload. You have the section over here on the right that is considered the accumulation zone, and then the section over on the left is considered the cooling zone. So as it's coming around, the operators hang components on the back-hand side. It travels the booth or the conveyor belt, accumulation zone, and then comes in. The very first section that we have is the yellow beam right above the control box. Inside that beam, there is photo sensors in there that actually measure the components for us. So what that does is it eliminates the operators having to run back and forth every time they hang a new size of a fixture. So if they hang a 4 foot, 2 foot, 12 inch, whatever it may be, they would have to then run back and forth to turn guns on and off based off of that component's length. From there, usually around lunchtime, they don't care no more and all the guns are spraying 100% of the time. So we're wasting a bunch of powder doing so. So with the photo cells in there, it measures the length of the component, the width of the component, the gap in between each one, and then if you look at the flight bars, there's about a 3-foot gap in between each set of flight bars. So based off of those measurements, as long as our program is selected properly, it comes in to the pit 6 inches before it hits that first set of guns. It's going to activate the guns that measure the component coming through. If it didn't see a part, it won't turn those guns on. It comes out, it's been sprayed, it goes to the oven, it gets cured. So that eliminates the manual portion of turning guns on and off, which then in turn saves us a bunch of money because we're not wasting powder. From there, once it gets into the pit, the box, there is a grounding rod that connects to the flight bars. From there, it gets transferred to the component. Then the component has a negative charge on it. Once the powder is dispersed out of the guns, there's an electrical diode at the tip of each one of those nozzles that puts an electrical positive charge into the powder. From there, positive and negative basically magnetize to each other. It sticks. Whatever does not stick to the component gets sucked to the bottom of the floor, into the exhaust tube. 25% of the powder on a day-to-day run goes straight to the trash. The other 75% will go into the cyclone, gets funneled down, gets filtered out. From there, it'll accumulate in the bottom of that cyclone there on the funnel. Once it hits a certain point, it hits a sensor. The pinch valve opens up, the air pump turns on, it sucks that powder back out, and then mixes it with fresh powder, gets resprayed, rinse and repeat. As long as we don't shut down, clean out, or color change, we're recycling 75% of our powder on a day-to-day run. If we do a shutdown or a clean out, it has an automated control panel up there. You select your settings, and then pumps out as much powder in the system as possible. You can put it back into a bag, tie that bag up, come back in the next day, next morning, put that bag back in, and start respraying. On a color change, we have to do a couple extra things. We do that same exact clean out, and then the guys are forced to then drop this pivot arm, open it up, they then stick their little head up in the cyclone with an air hose, and they're blasting off all that powder in the cyclone to make sure we don't have any powder accumulated on the walls of the cyclone, as well as inside the box, inside the spray booth. Up to a tablespoon or more of powder stuck in the crevices of any one of those sections will then contaminate your next color change. So we want to make sure we get in there and blast as much powder off as possible. From there, everything is then sprayed, stuck, goes to a 40-foot long infrared oven, and that's where it starts to cure and bake on and set the component. A couple QC checks we do. We have this fixture here, which is a test fixture that's been put out of commission. As you can see, my probes are falling off. First thing we want to do is check the spray pattern and make sure we're putting enough powder on the component. So even at a 1 mil, you may see some gray spots up in these top corners. It is still covered. I can measure on it. It'll have probably about 1.5 mil, but you're still able to see a little bit of gray on it. It is still within the powder vendor specifications. Obviously, if it's too noticeable and it's too much gray, I'm going to then respray it or bump it up a little bit to get rid of the gray. But on some of the fixtures up in these crevices, that then get a lamp holder bracket or something on it, and you take it apart and basically it's slightly gray, but it's still within spec, right? So if it's oversprayed, then we can go back to the programming section. We will decrease our powder spray usage and then respray it, remeasure it to make sure we're always maintaining that window. Easiest way to do so is a damage control test. I will grab an inexpensive component, I will spray it on a normal setting, I will run it through the paint booth or the oven, let it cure what it's supposed to be cured at. I will take it, I'll bend it in half, drop it, fold it, whatever, hit it with a hammer. If that powder doesn't chip after I fold it in half, I'm curing, I'm not even going to worry about chipping any farther. If I touch the ground and it pops off, then I'm going to dive in and figure out what's going on. And that's the first check, is measuring the powder. Second check is going to be running it through the oven. So these here are basically temperature probes. It hooks to a data pack box that will then run through the oven with the fixture. That is going to then relay information back to the data pack that I can download and then print out, and that gives me the graph. So the graph is basically mimicking each one of these pins needs to hit a certain temperature for a certain time. So the temperature that needs to be cured at for this powder is anywhere from 400 to 425 degrees for 8 to 12 minutes. So pin 1 and 6, which is top and bottom on that graph, did not maintain temperature for long enough. So the fixtures that were ran during that day were more than likely going to start chipping on these top edges, these corners, and the bottom corners. So from there, we try to run this probably about once a week, once a month at most, if we're running some oddball parts or if we're noticing any chipping issues. I can run up to 6 months as long as I'm not noticing any chipping issues on the damage control test. I'm not even going to run that. From there, I will take that information. I know my oven is my problem now. This thing measured out properly. My oven's not set properly, so I will then go back to my oven. I can then try to fine tune the burner zones to increase temperature. If that does not do anything, then I need to go start checking my gas valves and all that good stuff to make sure everything's operating properly. If that's still operating properly, but I'm still having chipping issues, more than likely my burners may be contaminated, they need to be rebuilt, I have ash over, or whatever it may be. It kind of gives us two different directions to go in to kind of pinpoint our issues, whether it be the spraying portions or the curing portion. From there, it comes out, it goes to a cooling zone, sets for about 5 to 10 minutes. From there, the guys take it off, put on the pallets, and then it gets spread out through the building in which direction it needs to go. So I have a target goal of 6 weeks from previous sales that I want to maintain. So every Friday I download a report of those part codes. I find out what we have in stock in all fulfillment centers. I find that number, I put it in my Excel format. It gives me a percentage of what I have versus what I need for 6 weeks. Monday morning, the team comes in, they get that list, and then they just hammer out those components. The lowest percentage, highest seller, where they get hammered out all day long to get that number up in stock. So you should never have to worry about an LED or an SLW LED T8 tube-ready fixture being out of stock. There are usually about 2,000 of them ready to go at all times in the warehouse, whether it be Port St. Lucie, North Carolina, Indianapolis, Vegas, whatever it may be. I try to backfill those top sellers in the warehouses. So they'll grab that body, 4 people per line, they all have that same exact roll, and they just hammer out that stock list all day, every day, unless I get to a point to where I'm 90% stock filled and I'm now backlogged on my orders. They may get an order from time to time to kind of bring out my outstanding orders down a little bit. But most of the time, I would say 90% of their time is just building stock. And then the 2 little pods that you see over here, the first pod is sub-assembly. So if you buy a chopper with a door frame, that door frame is considered sub-assembly. We have one in the tote. If there's 100 choppers, 100 door frames need to get built, I don't want my assembly line spending 60 seconds per door frame building that thing on the line while the fixture's being worked on. So this lady will get the order probably 2, 3 days, 4 days ahead of time before the bodies have even made its way through the facility. All the doors will be ready to go. Once the order hits the line, the tote goes to the packer. Packer puts the door frame on right before it goes into a box. She'll do that for all sub-assemblies. So if I used to test those on the line and it failed in that 3rd stage operation for a bad driver, unbuild the fixture, rebuild the fixture, retest the fixture. So that could turn into a 5-minute process because a bad test. To where she's gonna test it at the beginning of the process, check it right then and there, and then it's gonna get deemed bad from the get-go, and then sent back to vendor, and then replaced. So it saves me a bunch of time and money. This one here, this is the IB LED, so this would be that fixture up there.
Right, like your flat panels, like 2x4s, 2x2s.
All the BLPs, TLPs, flat panels, those are all brought in.
Okay.
We have a prototype that we've been working on for an in-house manufactured backlit panel. It's not have been passed through testing phases yet, but we're looking into it to see if it makes sense. So some of those things, if you can buy them for next to nothing, it's going to be hard to justify. Yeah, so we're trying to get a sample to where we can manufacture it relatively close to what we're buying it at. If it's $1, $2, $5 more, some people may want to buy that, being that it's manufactured here in the US, so we're working on a backlit panel. And then we're constantly looking at other options that we bring in that we can manufacture for roughly the same price or not cheaper. Probably about 6 months ago, we started offering any lineup that we used to purchase, brackets and bullhorns, manufactured in-house. So on the backhand side, we have a fabrication room. We have bandsaws, welders. I have a CNC pipe bender, and then we'll cut, mill, and bend whatever we want, and then powder coated.
We're not doing poles here, but we have, I think, 3 pole vendors. We started out with 2, and then we had to go to a 3rd for different reasons, but part of it was a lead time, but now we're doing poles, so you guys are looking for quotes on poles, you know, different material, different configure, square, round. We can do poles as well too. So you get your poles, your brackets, your bullhorns, as well too. So
and the good thing about the brackets and bullhorns, I mean, our overseas vendor or even in-states vendors, the price on it, you know, a 2-post 90, like $120. We're now manufacturing for like 40, 50 bucks. So big cost savings manufacturing those. I mean, it cost us a little bit to get into it, and there was a learning curve. You know, the first day we hooked up the pipe bender, we broke it. We were behind by 6 months, but we figured it out. And now that cost saving goes over, you know, on the whole lineup. So if you ever bought a bracket or bullhorn before we started manufacturing, they were expensive. And the lead time was 6 to 12 weeks. Now you buy any one of our bullhorns for 7 to 10 business days. From raw pipe, cut, bent, milled, powder coated, shipped. And that goes for any manufactured goods. I'm almost averaging on every manufactured fixture 7 to 10 day business lead time. And then if we have an issue, we can rush it through. The poles, I'm not involved with the poles.
If I can get the bullhorn, that's great, but I don't have a pole.
Yeah, we got Planet. The poles are, well, they used to be like 8 to 10, but they're probably running about 6 now.
About 6 now?
So, yeah. This side basically is our outgoing. We're gonna make a quick loop around. We'll see the inbound side and we'll come around. But this is our outgoing section. That pallet has to be clear wrapped with the blue tape on it. If it's not, that means someone probably repalletized it. It might have black plastic on it or something. So we're trying to tell them this is a picture of what it looked like going out. Sometimes it doesn't make it there, but that's kind of one of the challenges that these guys are trying to make sure is consistently overcome, is making sure that when they get the product, it's like this, is, with the wrap and everything, the blue tape on it going out. Although some truck lines are getting a little hip to it, so now they're trying to put some blue tape on their stuff as well. So, and again, these are all of our fixtures. These are all the IBLEDs that he was just talking about over there. So this is all of our fixtures. These fixtures are basically, it's a legacy product, and this is basically going to be anywhere from 4 boards to 10 boards, depending upon what the application is. But that curved array allows you to go from, say, 4 LED strips to like 10. So obviously you can see here, it's a little bit more than what you might see over there. Or at a branch, they might just have like an IBLED with like 4 boards. So obviously in a warehouse, you're gonna have maybe a higher lumen output that's required. So you'll see a larger high bay. We actually have room to expand. I don't know if they told you guys that. We have room to expand our coverage, our area. So this is Indianapolis. These are customers of the Indy North, Indy East, Fishers branch. So we have Vegas, Charlotte, Florida, and Indianapolis as our distribution centers.
12 to 15% of all orders are independently audited, and every single order is double checked by a quality control specialist for completeness.
How does quality control work as far as TAMCO is concerned? Product manager will decide for whatever reason he needs a new product, say smocks. The first thing that happens is they get samples in from different vendors. Product manager will look at it and he will say, okay, I like this one, this one, this one, and maybe this one over here. He will then send them down to quality control and we do a full inspection on it. We look at UL standards, ETL, CSA, which by the way are basically all 3 the same. We'll look at other standards that are out there, and then we'll set our own standard. Those standards are, we call the baseline, that's the bottom. We won't go below that, but there's nothing that prevents us from raising the bar, okay? Which we do in several ways. So anyway, we get the product here, we look at it and we go, this is okay, no, that's not gonna fly. So we send those reports and the product back up to the product manager. He goes back to the vendor. Usually at that point, he'll pick whichever vendor he's gonna use. And then we go back and forth 2 or 3 times with 2 or 3 different samples before we finally get the one we want. Now, this is where the interesting part comes in. How are you sure that you're getting the product that you're supposed to be getting? And as in today's world, almost everything is made out of plastic. How do we know what plastic is the right plastic? How do we know we're getting what we asked for? That's where this comes in. This is called an FTIR. This machine allows someone who is not a chemist by any stretch of the imagination and not a very bright person to begin with, and I'm speaking myself here. And what it does is it fires an infrared laser through a little crystal right there. In this case, it's a diamond. And it reads the reflectance that comes back out of the material. Every organic compound has a unique reflectance. It reflects back a unique spectrum, sorry. Okay? And these are different compounds here. You can see that they're different. And by the way, this is not how the machine tells. This allows someone like me to see. For example, if you look here, these 2 here are both polycarbonate. Now they've got some other things in there, and I would also point out that we're looking at the full spectrum here. I can make this very granular, and I can only look at it very narrow, and I'll see a lot more detail. 2000 to 2200 will look very similar to this section right here if I zoom in on it. Okay, so it allows us to be very, very precise. And this just gives you an example of the different spectrums look like. Now, you're not going to tell at some point something matches by doing this. There's no way. You can't. But the machine can. And if I select, I'll pick this top one here. And I'll hit search. And it comes down here and it gives me a match. A percentage of match. In this case, it's 98%. Okay. Now, we would expect 97% or better. That's how we maintain consistency from batch to batch. When we have that first prototype that we know is perfect, we know it's the right item, that's what we want, we capture that spectrum and save it in our library so that when I look at that product again in a month or 5 years or 10 years, unless we've changed it, that spectrum had better be the same.
And the glow wire tester. How many degrees?
The glow wire burns at 1600 degrees Fahrenheit.
1600 and can't set on fire that UL listed wrapping paper.
Yeah.
And then once that is wrapped, it will go just down the way a little bit so they can bill it out, find out what carrier that's going to go with, and that will be, you know, shipping labels stuck on that pallet. Like for example, SDs or R&L or whoever. Everything is QC'd. Once that is done, everything is boxed up and packaged, and then they'll go through the billing process.
We are back on the road, and if you, my friend, made it through this entire video, you're a different sort of breed. But my mind has been expanded, and I hope yours has been too. Subscribe to Electric Pro Academy for real skills to make real money.